Okay, we are going to talk about 6B measures of variation. I will be going back to the graphing calculator to, I'm going to post another video that I recorded on Friday that it's going to help with this as well, but I am going to go back to the graphing calculator and show you how to do some of this on the graphing calculator. We've already talked about in class the way to do this the long way is to add up, if we want to find the mean and the of both of these banks. So we've got, what this situation is we've got big bank and they have 3 waiting lines and their wait times are 4.1 minutes, 5.2 minutes, 5.6 minutes, so on and so forth. So they've just recorded these people's wait times. Best Bank, they only have 1 line, but here are their wait times, okay? And so it asks you to compute their mean and their median for both of these, for Best Bank and Big Bank. Well, the way that you compute the mean is you add up all of these entries, 4.1 plus 5.2 plus 5.6. You get a total for that, and you divide by how many things there are, okay? And the way that you get the median is you find the number that is in the middle. If there are 2 numbers in the middle, then you add those 2 together and divide by 2. And we in the first lesson, I guess in 6.1 or 6A, we went over this step by step how to do this. So I'm going to really focus on using the calculator to show you how to get these responses. So, or how to type these in the calculator to get your mean and your median. So I'm going to go to the calculator screen and look at this real quick. So if you've got a TI-84, it will give you a lot of this information. If you go and you hit the stat button is right beside the gray arrows and right across from the alpha button. If you hit stat, what you want to do is we want to edit. So we're going to hit enter. And you should get list 1, list 2, all of those things should be at the top of your screen. Are you good? Okay. So now I've got something in my list. I don't want it to be there. So I'm going to hit my arrow and go up and then hit clear, which is right below the arrows, and go down, and that'll clear out my entire list. So now I'm starting with just typing my numbers in. So 4.1, 5.2. These are the numbers off of Big Bank. 5.6. It takes a minute to type this in, but the value of it is it's going to do a lot of the calculating for me, and it kind of helps me from making some of the mistakes I might make. But 6.7, 7. I'm just going in, typing all these things in. It's taking me a little bit longer because I'm having to do this with my mouse, but this first list is for Big Bank. Now I'm going to go over and I'm going to type in, I'm going to use my arrow over, and I'm going to type in also the list for Best Bank next. Okay. So went to stat, and I'm editing that list, those 2 lists. So other value of this is this thing that we're using doesn't just calculate the mean and the median, it calculates almost everything that we're going to talk about today. I think the only thing it doesn't calculate that we're going to talk about today is the mode. And the mode is the one that's listed the most, and that's kind of easy to come up with. When you put your numbers in order, you can kind of see the number that's listed the most. Sometimes there's not one that's listed the most. We talked about that last lesson, that there could be no mode. So all I've done is type my list 1 and my list 2 in my calculator, okay? So I want to find the mean and the median of both of these lists. So I'm going to hit the stat button again. Okay, this time I want to calculate something, so I'm going to arrow over to calculate. And I want to do that very first one that says 1 var stat. So I'm just going to hit enter. Now, this is important. So it says list, and then it has L1. Well, if I want to look at Big Bank first, that's going to be L1. When I want to go to Best Bank, remember we typed those into L2, so we'll need to change that. But for right now, we do want to look at Big Bank. That was it typed in list 1. And so we're just going to enter all the way through those, enter at calculate, okay? X bar is a fancy way for saying mean. Yeah, just hit enter all the way through that list. X bar means mean, okay? So we've got a mean of 7.2. We're going to write that down in a minute. This right here is the summation, so 79.2. This would be what all the minutes were if I added them all up. Okay, this right here, this is all the sum added up squared, which we will be using that in a minute as well. Okay, this, we're not going to really talk about this much, but this is the standard deviation, 1.869. We are going to be discussing what that is today. N is equal to 11 means how many terms we had. That would be what we divided by. Okay, if we found the mean, we would add up all the terms, so we would get 79.2 divided by 11. We've got our minimum term, which is 4.1 listed here. We don't have to, and remember, it's nice, we don't have to type these numbers in order. Quartile 1 is something else we're going to talk about today, 5.6. If we keep scrolling down, we've got a median also of 7.2. We've got quartile 3, which is something we're going to talk about today, is 8.5, and then it tells us our maximum value is 11. So we can get all of this information from this table. So what we need to remember is that the things they asked for was our median was 7.2 and our mean, which is X bar, is 7.2. So those are the things we're going to want to write on our table when we go back. They were both the same. The mean and the median were both 7.2, which does not happen very often. So when I go back to my notes, I'm going to jot that down real quick. That the mean and the median of Big Bank were both 7.2. Okay, now I've already typed in all the stuff for Best Bank, but I put it in list 2. So I'm going to go back to my calculator and I'm going to find the mean and the median of list 2. So to get out of this screen, you would hit second mode, which if you look above mode, it has a quit. So we kind of want to get out of that. We don't need that information anymore. So I hit second mode. I'm just looking at a blank screen. You just hit second mode. So the second and then mode is, okay. That's okay. So second mode, and then now we're going to go to stat again. We do want to calculate something. Okay, we do want to calculate the 1 var stat, so we're going to hit enter. But this time we do not want this to say list 1. We want it to say list 2. And if you'll look down right to number 2 at the bottom of your calculator, like where the number 2 is, there's an L2 above that. Okay, the bottom of your calculator, if you look at number 2, there's a little L2 above that. Mine's in blue. But if I want that L2 to show up, I have to hit the second button, and then number 2 will change that to L2. because I type those in list 2. A lot of people just keep typing over list 1 so they don't ever have to change it, but it's not that hard to change. You can just get right, type over it. So we're going to hit enter all the way through that. Okay. The important things that we're worried about right now are X bar, which is the mean. So the mean is 7.2. To get the median, we need to scroll down through these, and it looks like the median is also 7.2, which is weird that you would get the same mean and median for both of these, but that's what we got. So let's go back to our paper. So we've got a mean of 7.2 and a median of 7.2. Okay. Says based on this information, which bank is better regarding wait times? And I mean, if we just use the mean and the median, it doesn't look like there's any difference, right? Okay. But in reality, we're probably going to have more unhappy customers at Big Bank than at Best Bank. So I'm just going to say, so probably why? And what would be the reasoning? Why would we have more unhappy customers at Big Bank? Let's look at Big Bank's wait times than Best Bank. I don't know if you guys have ever been through like if you're going through a drive-through. These are people that are waiting kind of on the teller to help to wait on them. Okay, I don't know if y'all been through a drive-through before, but it's frustrating whenever you are somebody, maybe you see 2 cars in front of you, they get their food and really quickly, the next car gets theirs really quickly, and then it takes you forever to get your food. In fact, so long that they tell you to go ahead and pull up and park in the spot up there. Have y'all ever been there where they're like, yeah, you pull up there and you're like, I don't have time for this, and it gets frustrating. So if the wait times are this is what we're kind of talking about today, this variation, this term variation. If the wait times there's a lot of variation in there, it makes people upset because they don't feel like they're getting equal treatment. Okay, so at Big Bank, we go from somebody having a wait time to 4.1 minutes all the way to 11 minutes. That's a lot of variation. Okay, at Best Bank, we have a wait time of 6.6 to 7.8. Those wait times are a lot more equal. Y'all, do you agree with that? So even though we've got the same mean and the same median, we're going to have to look at customer service. We're going to have to look at the variation of times. And this is what these 2 charts down here have. They've actually graphed the amount of people that waited 4 minutes, the amount of people that waited 5 minutes, 6 minutes, and we've even got one that had to wait 11 minutes, okay? You can see that their variation is very spread apart. That does not make people happy. They do not feel like they're getting treated equally. This 11-minute person, I guarantee you, does not feel as happy as this 4-minute person, right? Because they're not seeing that, okay, this is about the same. Even though these people are averaging 7 or 8 minutes, we don't have the spread of variation. So usually people feel like, okay, well, this is just how this is going. I'm going to have to wait about 7 minutes because the person in front of me waited about 7 or 8 minutes. So they feel a little bit more content. So the difference in customer satisfaction comes from the variation in waiting times at the 2 banks. Big Bank has a wider variation of wait times. Best Bank customers feel like they are being treated more equally. So which bank appears to have more variation? So we would say Big Bank has more variation. Big Bank has more variation than Best Bank. And basically, the people at Best Bank feel like they're being treated more equally because their wait times are about the same. When you start delving into project 2, this is the stuff when you're starting to analyze your data, this is the stuff you're going to want to use for proof that you know what you're talking about, is that you've got to look at all the numbers. And we did look at, I can do it if you don't. We did look at mean and median, and we decided that mean and median didn't really tell us a lot about this situation, right? They were all the same. So we had to go look at something else, some other means of talking about data. And the thing that we looked at was variation. We did a graph of the variation and talked about the spread, how far apart the spread of the data was. And that's what kind of went, oh, I can see why these people might be a little bit more upset, because they feel like they're not getting treated equal. Their variation times of their stuff is not the same. Okay. Another something that you can look at is range. Range is a very easy calculation to come up with. The simplest way to describe the variation of data set is to compute its range. Range is simply the highest value minus the lowest value. Okay, you probably have been exposed to that at some time or another. Range just simply means you take your highest value minus your lowest value. So it says, for example, the range for Big Bank is 11 minus 4.1, which is 6.9 minutes. Best Bank's range is 7.8 minus 6.2, which is 1.2 minutes. That's a vast difference in ranges, which is going to affect the variation most of the time. Okay, so we are going to we're going to come back to this example 1 in just a minute, partially because, actually, we go ahead and do it. It says, consider the following 2 sets of quiz scores for 9 students, which has the greater range. Would you also say that this set, or also say that this set has the greatest variation? Okay, so here we go. Quiz 1, if we're calculating the range here, calculating the range for quiz 1, well, the biggest score they have is 10. Then you subtract the smallest score, which is 1, and 10 minus 1 is just 9. Okay, on quiz 2, for calculating the range, the biggest score we have is 10, the smallest score we have is 2, and 10 minus 2 is 8. So which has the greatest range was one of the questions. Well, the greatest range would be quiz 1 has the greatest range. And would you also say that this set has the greatest variation? So I would argue on quiz 1 that this number right here, it looks to me like on quiz 1, every single person scored a 10 except for one person, right? And they scored a 1. Okay, I would say that that 1 represents an outlier. That's not normal, right? If everybody else scored 10 and this person scored 1, something happened. They didn't study, or maybe they didn't see that. I've had this happen before. Students turn in a test and they didn't turn it to the back page, right? So they only entered the front page. But something happened because everybody else made a 10 except for this one person. So this score is an outlier. Something's wrong with it. So I would argue that the variation in quiz 1 is actually not very big at all. Most people scored a 10. If we were to graph a bar graph of that, right, even if we were to include the 1 on that one, we would have like a score of 1 down here with one little thing, and then 10 would be up here with almost everybody, right? Even though this had the biggest range, doesn't necessarily mean it has the greatest variation. You kind of have to look. That's not this one we shouldn't even be counting. So this one actually has the greatest variation. We actually have scores that are pretty spread apart from 2 all the way to 10, right? In fact, we've got 1 apiece from 2 all the way to 10. So the bars would just be 2, 3, right? They would all be on the same level. So this is a lot more, quiz 2 has more variation. If this was the bank, the people would be very upset here because they'd get up there. I don't know how long they're going to take. It just depends on the personality probably too. But okay. Now this thing that we're fixing to talk about is how to draw a box and whisker plot. Okay, so I'm going to show you how to do it by hand first, and then I'm going to show you how to do the calculator next. Okay, because all the information that we typed in the calculator is still there, and it gives you all of these numbers. When you're doing a box and whisker plot, it's important that we're going to talk about what this lower quartile, middle quartile, upper quartile mean in a minute. This lower quartile on your calculator is going to be called Q1. The upper quartile is going to be called Q3. The middle quartile is called the median on your calculator. There are some important numbers when you're doing a box and whisker plot, which sounds crazy, but you'll see what I'm talking about in a minute. There's some important numbers that you want to consider. These three are very important, and also your lowest and your highest number. Your lowest number and your highest number. So a lot of times we call this box and whisker plot a 5-number summary. And the 5 numbers come from quartile 1, the median, quartile 3, the lowest number, and the highest number. Those are your 5 numbers in this 5-number summary, okay? So the first thing you want to do when you're doing a box and whisker plot by hand, okay, is you want to pick out the median. And the median is the number in the middle. And these big bank and best bank actually have a number in the middle because there was an odd number of things. So this 7.2 is our median. It is our number in the middle. Okay. Then you want to pick out, now I've kind of got divided it. Sorry, my brain's not working. Starting to stutter. Divided this in half. And we ignore that 7.2 in the middle that we just took, and we knew that that was the median, and we talk about the other sections. So then we've got, oh, okay, well, they're pointing to this lower quartile, which we said on your calculator is going to be quartile 1. Well, that number is the number in the middle of all of the first half, of the bottom half of numbers. So that quartile 1 comes because that number is in the middle of the bottom half of numbers. This one comes because it's in the middle of the top half of numbers, and that's quartile 3. So it's in the middle of the top half of numbers. So when we're picking out our 5-number summary, the lowest value on, this is big bank, the lowest value on big bank looks like it's 4.1. The lower quartile, or quartile 1, is 5.6. The median was 7.2. Quartile 3, or the upper quartile, is 8.5. And the biggest number was 11. So those are your 5 numbers in your 5-number summary. Okay. We're going to do the exact same thing for our best bank. Well, best bank's lowest value was 6.6. Their lowest quartile, or quartile 1, is 6.7. The median is 7.2. Quartile 3 is 7.7. And the highest quartile is 7.8. So those are our 5 numbers for best bank. Pretty easy, right? It's going to be really easy in a minute when I show you the calculator does it for you. But so what they've done to make this thing that looks like a box and whiskers is we've got, if you look, we've got, it didn't matter which one they put on the top or the bottom, but we've got best bank and big bank. Let me see if I can raise it up just a little bit higher on the screen. Okay, So they could have switched these, it doesn't matter, but they needed to label one of them best bank and one of them big bank. Okay. Then we knew that the wait times went from, well, we knew that our range was from 4.1 was our lowest of any of them, and 11 was our highest. So we had to make a scale that at least went up to 11. Okay. And so they went ahead and started it at 0 and go to 12, which makes sense because they've got to at least go to 11. So they went one past. Okay. And the bottom, it says waiting times in minutes. You always want to label your graph. So when I'm doing this, the first thing that I do is I go and put marks at each one of these important things. So I would deal with this first one first. So I would say, okay, 4.1, which is about right here. I would put a line right there. 5.6, which is our next number, a line right there. 7.2, 8.5, 11. And so I go ahead and mark all my lines down, which are my important numbers. Okay. In the middle section, it's going to be connected with a box, which is why it's called box. And on the outside, you're going to draw your whiskers. So you connect the middle ones with a box, and the outside is your whiskers. They're calling it a box whisker plot. Box plot is another way to say that. So on Best Bank, I'm doing the exact same thing. I'm going to take my numbers in my 5-number summary, 6.6, 6.7, 7.2, 7.7, 7.8, and I'm going to, now some of these you're going to have to estimate a little bit because we're going by decimals, right? And they went by, and they're going by ones down here. So it's not going to be perfect, which is one of the reasons why they went ahead and put the numbers with it and not just the box, not just the lines. So they went through and they put a line for 6.6, 6.7, 7.2, 7.7, 7.8. And then they are connecting those, connect the ones in the middle with a box, and the ones on the outside get whiskers, which there's almost barely see the whiskers. On a box and whisker plot, it's really easy to see the variation here. Really easy to see the variation. You can see that Big Banks is way more spread apart than Best Banks. Best Bank stuff is really close together compared to how spread apart the data is for Big Bank. So a box and whisker plot is a good way to look at variation. So how do we get these numbers on the calculator? So I'm going to go, I've already got the stuff there because we already typed in the numbers. So if we go back to our calculator, this was, let me just clear this out. Start over. So second quit, second mode, get you out of that screen, second quit, second mode. I'm going to go to stat. I'm going to hit enter. I'm going to calculate because I've already typed the list in for Big Bank and Best Bank. I'm going to hit enter. This is looking at list 2 first, which is fine. It doesn't matter what list I look at first. List 2 is fine. We'll change it back to list 1 in just a minute. But look, here's where your box and whisker 5-number summary starts. Minimum value is 6.6. If you look down here, quartile 1 was 6.7, and they're calling that the lower quartile, right? The median is 7.2. Quartile 3 is 7.7. The maximum is 7.8. So those last 5 numbers there make up your 5-number summary that's supposed to be your box and whiskers. 6.6, 6.7, they should be the same ones we just came up with. 7.2, 7.7, 7.8. The box and whisker plot, your 5-number summary, which is your box and whisker plot. So if I go back, I need to, let's practice making this list 1 again, because that's something that's easy for you to forget about. So if I go back to stat, I'm going to just second quit, clear this out. Okay. So I would go to stat. I do want to calculate something. I've already typed my list in, so I want to hit enter, but this time I don't want list 2, I want list 1. So I'm going to have to change this to say list 1, and list 1, if you look at the bottom of your calculator, there's a right over number 1 has that L1. Second one, we'll change it to L1, then we can just enter all the way through that. And our 5-number summary is going to start with our minimum, which is 4.1, right? And it's going to go quartile 1's 5.6, 7.2, 8.5, and then our last of our 5-number summary would be our 11. So it kind of gives us the answers to that. It doesn't kind of give us the answers, it gives us the answers to that. So that's another place that you can get them if you can get your calculator function on this, okay? So we need to talk about, is everybody okay with that? Standard deviation. At the bottom, which is something else we can do on our calculator, but I'm going to show you how to do this. So there's a formula for how to calculate the standard deviation. Okay, and it says that we've got this crazy formula, which we'll talk about. But in order to do standard deviation, you have to have this information. So I'm going to kind of set up a chart over here. And on our chart, this is the stuff we want to put. I'm going to try to write as neat as possible, but we need to take into account, we've got 2 banks, and I didn't leave enough room for that, so let me put that real quick. We are talking about big bank. Okay, so I'm just going to kind of divide this into, don't write big, we got a lot of stuff to put here. So we're calculating standard deviation. Kind of talk about what standard deviation is after we get this calculation. Okay, I'm just going through and writing down my table right now. So these are just the numbers they already gave us for the wait times that we had to, I guess the people waited in line to get to the front. Okay, so all I've done is write down the wait times. To find the deviation, you need to take the time minus the mean. The time minus the mean. Okay, we already found out the mean was 7.2 for Big Bank and Best Bank, but the deviation is just the time minus the mean. So 4.1 minus 7.2. which is just kind of a pain to have to do all this. But if we're going to have to calculate it by hand, this is what you would have to do. There is no way around it. Sorry about that. Okay, then they take these numbers and square them. So basically, when you square a number that is negative, that means you're doing negative 3.1 times negative 3.1, that number is always going to be positive. So when we square these, every single one of them should be positive, because the negative numbers times when you square them, they're automatically turn into positive. And of course, the positive numbers are going to be positive when we square them. That was a pain, right? To go through every one of those and square them. So it's going to be important. So these are the main numbers that go into calculating this standard deviation. And so if you go back, I know that I've got the thing right here in front of me, so I don't have to do that. But if we look at the formula for standard deviation, it said that you need to take the square root of the sum of deviations from the mean squared. So I'm going to put, and the way you write this, I don't know, that formula doesn't write it like this, but this means summation. So the sum of the deviations squared. Okay, you want to add all those up, and we want to divide it by the total data values, which we would call n minus 1. So in this case, what we're going to have to do is take all of these numbers, these deviation squareds, we're going to have to sum them all up. So we would do 9.61 plus 4 plus 2.56 plus 1. We add all those numbers up. And when we do that, we're going to get a total of 38.46, which is what goes, that's what that means. So square root of 38.46 divided by n minus 1. Well, there were 11 of these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values here. So on the bottom, we would have 11 minus 1. When you do that calculation, okay, when you do that calculation, it comes up to be, hard on me, 1.96. I'm going to write that right up here. 1.96 is what you're going to get. And that would be the number of minutes. 1.96 would be the number of minutes. So what does this standard deviation mean? When we look at our data, what that's saying is that most of the times are within 2 minutes, give or take, of the mean. Okay, so the mean was 7.2. So if we subtract 2, because 1.96 is very close to 2, okay? So if we take our mean of 7.2 and we subtract 2 from it, we would get 5.2, right? If we add 2 to it, we would get 9.2. And so what they're saying is if you add or subtract 2 from your mean, which is at 7.2, you're going to get the majority of your data in that value, which is true, right? There's only 4.1 would be outside of that, and 11 would be outside of that. 9.3 is barely outside of it. So they're saying most of your data is going to lie in between that plus or minus 2 minutes from your mean. Okay, which makes sense. I mean, the standard deviation is talking about your spread of data. I'm going to scroll back up here real quick. It's talking about your spread of data. And when you look at the difference between these two, this one's saying, oh, this number is probably about 2 minutes apart. And we just did big banks. We're fixing to talk about best banks. I don't think we're going to do it today because we wouldn't even have time to write all that down. What do you think about best bank? So big bank, look, their data is really spread far apart, right? Best bank, do you think the standard deviation is going to be bigger or smaller? Their data is a whole lot more compact. If their mean is 7.2 and we subtracted 2 from 7.2, that means we would have numbers 7.2 minus 2 is 5.2. So their standard deviation can't be 2 because it would be outside of what we have. We don't even go down to 5.2. If we do 7.2 plus 2, we would be at 9.2. So I'm going to estimate that best bank standard deviation is going to be a lot less than 2. Okay, well, we'll look at that on Wednesday, but theirs is going to be a lot less than 2 because they don't have, their data is really close together. One more thing. So we said 1.96, right? And I wanted to go back to the screen in case you still need to copy it down. Was the standard deviation. And this was on Big Bank, which is list 1. I'm going back to the graphing calculator real quick. So here was where we were at on our graphing calculator. Do y'all see a number that looks really close to 1.96? I do, right? It's this one right here, 1.96. That's your standard deviation. Okay, so that number is going to be important unless you would like to do all of those calculations every time, which I don't think you do. You may want to, but I don't think you do. Okay, so, and I think that that's the right, we're looking at the right one, but so there's the standard deviation. Look at this number, this x squared, that's kind of important. They took all the x squareds and added them up. If you take the square root of 608.7, let me just get out of this. That does not come up to what I thought it was going to come up to. So we're going to have to, what do we need? What do we need to get that standard deviation? We needed to have the list that was all added up. The calculator is not going to give you this 38.46, but that's not really important because it gives you the 1.96, right? Which is what they asked for. We had to do all of this work to get that. So you should be still good and be able to use your calculator to get that. So we will look at best banks values. I'll save this and we'll look at best banks values on Wednesday. I'll also start the next lesson on Wednesday because we're very close to being done with this one.